Greetings and salutations! Thanks for watching the video. I certainly do appreciate it. Today we're going to talk about the Fstab file in Linux systems. And since Linux is a Unix-like system, this applies to Unix systems as well. I got an email from a fella a while back. He was having some issues with his computer booting up. He had a lot of hard drives on his system, and he was getting some unpredictable results. And so therefore I kind of walked him through Fstab, and I thought about it when I was done. I was like, I have never posted a video exclusively about Fstab. We've talked about it in a lot of past videos, but that's when we were trying to get things done. So that's what we're going to do today. We're going to talk about it, and then we're going to take a look at different examples of how this can be configured on my network here, because I've got lots of different machines with different configurations. So what is the Fstab file? Well, it is a file that the kernel uses to find file systems at boot. And this is an integral part of the system, and without it, your machine will not boot. So every Unix and Linux system has one of these. Apparently, Mac, even though it does run on a Unix kernel, they've deprecated this system, so this doesn't apply to Macs. Just to let you guys know, they're doing something else. The name Fstab is short for File System Table, and that gives you an idea of what it is. And it is simply a file where each line has several entries which are delineated by spaces, or demarked by spaces. Whatever word you'd like to use. Separated is good. And each one of those entries could be considered a field, or it can be considered an argument, depending on how you look at it. A lot of basic Unix, Linux configuration files work this same way. It's just a space between different entries. Usually the very first thing would be what you're working with, and everything after that would be an argument to that. And that's kind of how this works. So the first thing on the list we have is a device. Now this actually refers to anything that we would consider to be a drive. So therefore a device, usually when we say that, we're talking about a block storage device like a hard drive, and that device could have many different partitions on it, and each of those partitions we can call a drive, even though the whole device can be called a drive. So I have been very careful to make sure that I have device and partition together here, just so folks don't get confused. The first thing that it's going to identify is the device, and there's a couple or three ways to do that. First is by UUID, which is a very special number that is generated when you format a partition on any storage device in Unix and Linux. And it is very robust because it doesn't change. You can change the label of the file system. You can unplug the file system and put it back in the computer in a different order. And as long as the kernel is able to find that UUID, it will be able to mount it. In the old days, we used to use device calls. You know, in Linux and Unix, when you plug a drive in, it's given a device call. So modern speak is dev/SDA, which stands for SCSI drive, and the letter is the drive letter, as you might be familiar with in Windows. And then each partition on that drive is going to have a number. And we'll look at that in more detail coming up here later. And then there are labels, which is something that when you format the file system, you can optionally add, and Fstab will happily look for labels. It's a bit more robust than a device call, but because labels can be wiped out easily if it gets reformatted or the drive something, anything can happen. So that's why they've gone to UUIDs. Of course, if you reformat it, it'll blow out the UUID too, so you can debate in the comments which you think is more robust. But you can change the label without changing the UUID. Next would be the mount point, and like I said, this is separated by some degree of spacing, whether that be tabs or spaces. And that's the directory where that partition will be mounted to. And my example here is /home. So when you have a Linux, Unix file system, it always starts out with the slash, that is the root, then you have directories under that. And in a Unix-like world, we take storage devices and we mount them in directories. So that way we can have as many storage devices or network shared devices hooked up to a system and they integrate seamlessly. You might be used to DOS and Windows where when you have a drive, it automatically assigns it a letter, A, B, C, whatever. You don't see B drives very much anymore, but they used to exist. That was in the floppy days, boys and girls. D, of course, is traditionally a disk drive, like an optical drive. Anyway, we're talking about Linux, not Windows. System file type would be the next thing, and that is just whatever file system that partition happens to be formatted to. This tells the kernel how to handle it. So ext4, ext3, ext2, any of those systems, XFS, ButterFS, ZFS, even NTFS can be mounted automatically by the system at boot. The next thing would be file system options. These are extra things that we want to tell the system to do. Since it knows already what file system it is, it usually loads a set of options that are standard, and then you can add to that. If you are happy with those and you don't really want to add anything to it, then under this particular field you can just put defaults, and it's very happy with that. But you can also use this to turn on options and give certain instructions to the kernel how to handle that particular file system. Like for instance, it's pretty standard with the root file system to mount that in a way that if it should unmount itself, then in an error type situation it can be remounted read-only. Finally, we have backup operations, which refers to an ancient utility called dump. Dump is not used very often today. I have never really dove into it too much, but essentially it's an old backup utility that when the system decides it's time to dump, it looks to see whether that partition is marked for backup. And a 1 is yes, and 0 is no. It's very rarely used today. Very rarely, if ever. But I'm sure it's still out there, and if you want to play with it, knock yourself out. This is Linux, you can do whatever you want with it. And then finally, it's the file system check order. At boot, your system runs a file system check, which is a utility called FSCK. And this particular system is looking for errors in mounted file, the file systems it's going to be mounting before they get mounted, of course. And that's important because it needs to fix those before you mount them. And the first one that needs to be checked is root, because that's generally the most important. That's where the system files are kept, all of the different executables and whatever are there. So we want to make sure that that system is working properly. And then if there are any other file systems listed in FSTab, then they will get a second pass. We want to make sure that that system that's holding the operating system is good, and when we'll get that mounted, now we can move on to the other stuff. Let's talk about editing FSTab. And I put this warning in here because you need to understand this is a very basic to the operation of your computer file that if you mess it up, guess what, boys and girls? You may be in trouble. You might have a system that doesn't boot. So if you are going to actually be working with this, you need to create a backup before you do. And how you would get back to that backup if your system is rendered unable to boot would mean that you would boot it off of a USB stick, and then you would mount the file system that your operating system lives in to this running file system, and then you would be able to go in and edit the file or swap it out to make sure that you have a good version in there. I'm going to show you how to make a backup here in just a moment or two, just so you know. If you don't know the correct procedure to do that, I'm going to show you how it's done. Now, you can find out what is already mounted using ls-block if you're going to be editing this file. So let's jump over here to this terminal and take a look at what we've got going on in this computer we're recording on. And ls-block gives you a lot of very useful information. First, it's going to give you the drive name and the drive letter. So in this system, we have one hard drive, it's SDA, and we have two partitions on it, and they are labeled SDA and SDA1 and SDA2. If I would add another drive to the system, it would logically be SDA-B and SDA-C and so forth. Then we have the MAJMIN there. That is some deep system stuff that I'm not even sure what it is. I read it in a book one time, but now I've forgotten it. It just simply tells the kernel what kind of block device it's working with. And then we have the size, which makes perfect sense. I'm not quite sure what RM is. If you know that, put that in the comments, because that's not ringing any bells. Of course, the size makes perfect sense. We're showing that in gigabytes, and on this particular machine, it says we have a disk. It's 931.5 gigabytes, which is a terabyte. Of course, it's showing the formatted file size here. And then we have a root partition mounted to SDA1, that's the system, and then the home partition is mounted to SDA2. SRO is the optical drive in this computer, and it shows that it's ROM, but it's not really ROM because it's a readable, writable drive. It's a DVD drive, and yes, I have reasons to have one of those in there, and I have them in most of my machines. That's a topic for another video. So that's how you figure that out if you're just trying to figure out what's already mounted to the system. Now, if you have no idea what your UUIDs are, then you can find that with another little thing here, and this one has to be run as root. So we'll do sudo blk ID, which is short for block ID. Now this gives you some very useful information. Okay. So now we have dev SDA1. It's listing the full UUID. There's no label here, so we don't see that. If we had a label, that would be the first thing. Apparently, after I rebuilt this system a while back, I didn't go back and label that drive. See, I like to format it to reinstall the operating system, but not my home directory. I want to leave that alone, and that's the benefit of having them separated that way. It says the system is ext4. We have a partial UUID number, and that's a short version. I'm not exactly sure how to use that. I've never run across any instructions explaining that. That has popped up maybe in the last 3 or 4 years on systems that I have been working with. So if you can shed some light on that, throw it in the comments. I would appreciate some feedback on that one. But obviously it's a shorter, more easy to handle UUID type thing. The second drive, we see that we have a label, which is home, and then the UUID, and then the partial ID. So that's how you know what that is. Let's see what else we've got to play with here. So what are the things that we can do? Well, we can mount an extra data drive, and we could do that by label if we wanted to. Now, this would be a drive that you would plug into your system, okay? So using a label is pretty robust. UUID is probably, as I said earlier in the video, the most standard way to do it, but labels don't change unless you either change the name of the label or reformat the drive. Of course, if you reformat the drive, you change the UUID as well. So either way, that's pretty strong. And if you unplug some drives and move them around, you don't have a situation where SDA becomes SDB and, you know, that kind of stuff. So that's one way to do it. Very simple and easy to do. And in this example right here, we're mounting a drive that's labeled data drive. We have created a directory under root called data for that to live in. That would be an empty directory. You wouldn't put anything in there. It's ext4. We're accepting the defaults, and it's the second pass. You can add more swap space here. You could add a swap file to a system that was hungry for swap. This is really not that big of a deal these days because most systems have a bunch of memory. However, if you are in a situation where you have created a system that's running in the cloud, let's say a virtual machine running on Linode or Voltaire or DigitalOcean, one of those services, and you originally set it up to only have 2 gigabytes of RAM and you want to be cheap, you can buy the extra storage space, but you could leave the system alone and you wouldn't upgrade the RAM. And let's say it was a server and it started to get busy. Well, you could always add swap space on your extra storage space there on a different drive, and you can do that with a swap file. I have a video up on how to do that. We're not going to get too deep into this. And once you've made your edits, you can test them by rebooting the system. You can also use sudo mount A, which basically rereads the Fstab file, and it'll remount what's there, and then if there's something new to it, you've added a line, it will mount that. I was doing some research, and they say sometimes with System D and certain things that you do that might not work. So if it doesn't, you can just go and jump down the rabbit hole to figure that out. Okay, so that is the basic stuff that you need to know. Let's talk about accessing this file just like any other file. Let's go back over here, and we're going to clear this screen with Control L, or you can type in clear, which I have been known to do. Especially if you're working on a terminal that doesn't support Control L, believe it or not, you might run into one. What were we doing? Oh, we're going to take a look at the Fstab file on this machine, and I'm going to show you how to make a backup very quickly. So we're going to use Nano to do this, because I like Nano. And we're going to go find the file. It's etc fstab, and of course we have to do this with root privileges. You could read the file, but you can't make any changes to it. So let's take a look here. This is what your Fstab looks like in a typical Debian/Ubuntu system, and you notice there's more commentary in here than actual stuff that's working. Any line that's longer than 80 columns is being continued here. So with Nano, to go look at that, you just use the arrow and move your cursor over there, and then it shows you the rest of the line. Some people, when they look at these videos, get a little confused if they're not used to that. And you'll see here that there's a lot of space between entries, and that's just done by the installer when it configures to try and kind of line things up so it looks normal. If you add something to this, then you can always just use a single space between fields, entries, arguments, whatever. What's right? I'm not sure, actually. Anyway, so the first partition that gets mounted, of course, is our root partition on this machine. And we have the UUID, and it goes to root. And let's see, we're here. Where am I? Okay, we go here, and if we jump over, we see that we get an ext4 file system, and then the options are that if there's an error that we want to remount it. Of course, we're not dumping it to anything because we're not using that utility, and we have first pass for FSCK. And then the second one, that's our home directory, is mounted after all that's done. It's also ext4. We're accepting defaults here because that's fine for a home directory, and it's the second pass. And then down here, since this is a pretty standardized Debian/Ubuntu/Linux Mint/ anything based on that family of Linux, we're using a swap file these days, which is about 2 gigabytes, and it's not mounted anywhere. It is swap. So the file system is swap, and then the options are SW. And of course there's no backup. There's also no file system check for swap. So that's how you would do that. Now we got a couple of ways here that we could make a backup of this file. And you can do it either way. There's no right or wrong way to do it. I'm going to show you both. So when you are in Nano here, if you hit Control and O, you notice that you're going to be able to write out the file, and it has etc/fstab. Well, if we just add .old to that, like that, see, and we press enter, it's going to ask us, really, do you want to save this under another file name? And we say yes. Alright, so it wrote out another file that is now fstab old. It has all of this original information in it before we make any changes. When we go to make our edits, let's say we do, then it'll ask us again about the file name. This time we take the old off and we can save it as the original. And then once we do that, we can either try Mount A or reboot the system and see if it takes effect. If it doesn't, well, at least we know we got an old one, right? So I'm going to go ahead and exit this. And what we're going to do is we're going to, I'm going to show you the second way of making a backup of a file like that. And this is actually probably the one that I would do instead of opening it up and doing all that stuff. So we'll do sudo, I'm going to do cp, okay, very important that we do cp. We give it etc fstab, and then we're going to give it the directory to work in once again, which is etc. We don't have to switch to that directory as long as we tell it which one. And we're going to do fstab again, but this time I'm going to type in .old and turn that loose. And I already have super user privileges. It's not timed out yet, so it didn't give me any whatever. So what if we have to put that file back? Something's not working and whatever. Assuming that you can boot the system and you're on the same system that you're made your changes to. Let's just say you put something in and it didn't work at all. It's not that the system didn't boot. Then it's super easy to go back. So we would do, let's go ahead and just restart this line, and we will do move. When we move a file, that removes the old file, okay? Because we are changing the name of the file, technically, is what we're doing here. And we're going to do etc/fstab, right? And this time we want the .old. We're going in the other direction. And then space, etc. This time around we call it fstab. And we need to put that slash in there. It ain't going to work, man. So yeah, we're going to put it back this way. And here we go. And it did it. So now we should have no fstab.old in there at all, because we've gotten rid of the backup file and restored it all at the same time. So we can check that with ls etc, and we're going to look for anything with fstab, fst, not sf. Right. I'm going to put a little star on the end of here. That way, if there's anything else called fstab, we'll see it. Nope. Only one file. So we don't have to worry about that. Just a little thing that'll help you do stuff there. Okay, let's jump into some other computers running on the network and just look at some other configurations and talk a bit about them. So this is my old Dell Inspiron laptop that I did a video about restoring not too long ago. Let's get into that one first, because it has some interesting things going on. And what machine is that? 16, yes. By the way, the SSH-in command is, oops, hold on, I gotta go over here and turn the thing back on. Be right there. I had it waiting to do this video, and it went to sleep. So, let's see if it's up yet. Oh, it's trying to find it. There it is. Ta-da! We're in. Okay. Clear the screen. This machine got called Studio because, for whatever reason, I thought this was a Dell Studio computer, and I have for years, and then when I was looking some stuff up, it's not actually part of the Studio series, but it's very close to it. So anyway, when I installed it, I called it Studio. So let's look at the fstab in here, and I'm going to make this super easy. I'm just going to cat it. Cat And this time around, we're not going to have the formatting. I don't know. Does that make it better or worse? Well, let's see what I can do here. I can highlight things. Actually, no. Let's go ahead and do it with Nano, because Nano is actually making it a little bit easier. So we'll go back over here, and we're just going to read it, so we don't want to... So I should be able to do this. Yeah, we're running without... It's unwritable. It's telling me that because, of course, I'm not doing this with root privileges. So it's an Ubuntu file, but it's a little bit different. As you can see here, the first thing that we have mounted is root. That's the same as before. It's ext4, and same thing. And that gets first pass. The next thing is the home directory. Same thing, default. We looked at that before. But then we have down here, our swap's a little different. There's a UUID there, because on this machine, we have a swap partition. It's not a swap file, which is actually the common way that used to be done years ago until we switched over to the swap file thing with the advent of machines that were stuffed with memory. We really don't need to set aside a partition. However, on this machine, when I installed it, I did that on purpose. And the reason why I created a partition because I wanted more swap. This machine only has 4 gigabytes of RAM in it, so I gave it 4 gigabytes of swap, which technically makes it have 8 gigabytes RAM total. But not really. Somebody's going to say, there's another comment coming up. Well, it doesn't really work that way. I know that. But anyway, you get the idea. So that is on that machine. Let's go ahead and get out of here. And we'll go into my son's machine. This is a different setup entirely. This one is running on Linux Mint. And he says that he could have some updates applied. I may want to go around and update some of these systems. Anyway, clear the screen here, and we'll do Nano again. Nano. And Nano is warning me yet again that this is unwritable, and that's okay. All right, pretty much the same kind of file here, except it looks a little bit different, don't it? So our root file system is the first thing that's mounted. If you look at this line right here, and that looks pretty much normal. It's an ext4 system, and we got the same sort of thing. But then we have a boot directory because this machine has EFI, or UEFI. And the UEFI has its own boot at start. We're using a very short, very short UUID there. And the reason why that UUID is so short, folks, is because this is formatted with VFAT, which is an update of the old Microsoft FAT file system that was used for DOS, which is simply short for File Allocation Table. And with VFAT, FAT32, or old FAT16, any of the old FAT file systems, this is as much of a drive indicator as you get. But it works perfectly fine, and we consider it a UUID here. Pretty cool, huh? The system does, at least. So, we're mounting as VFAT for this boot partition. And then the UMask, what is that? Well, the UMask has to do with permissions. So we're telling the system who can have access to this. And the UMask would be the opposite in octal of permissions that you would set with like the change mode command, okay? So if you see a UMask that's 0077, and we have 4 permissions in a row there, there's the special file permission, we're leaving that alone, we're not changing it. And then 0 would mean that we want the user to have full permissions. That's the root user. So the first one, there are 4 numbers here. I'm going down a rabbit hole, I know. Just be patient with me. There are 4 numbers here. The first one would be a special permission that's not ordinarily used except for files. It marks things like the substitute user ID and things like that, okay? And then the next would be root, and the root user it's set to 0, but he's going to have full permissions. Read, or she, read, write, and execute. And then everybody else on this partition, once it's loaded, you can't see it because the UMask is 7, which means that nobody has any permissions. It actually sets it to 0. So that's what that is all about. And it is saying that the system, uniquely here, I've never noticed this before, but it is saying that the system should scan this at boot up, and it's part of pass 1. It's got to be done along with the root system. And once all that's done and booted, then we can mount the home partition, which in this case on this system is on an entirely different drive. Okay, so there's 2 hard drives, and there's the swap file. That's in the root directory right here, swap file, and this is automatically created by Ubuntu and Linux Mint when the system is installed. Same thing with Debian. We're looking at Debian-based Linux here. So anyway, okay, so that's basically it and what I wanted to talk about in this video. We can go ahead and exit out there, and we might want to take a look at LS block here, just to make what you looked at a little bit more easier and an all-in-one space. You see we have 2 drives in this machine. There's SDA, which has UEFI boot on it, and then it has the system drive, and it's a pretty small drive. It's a 64 gigabyte SSD that I've had forever and simply won't die. It's a SanDisk, and then we have a 500 gigabyte SanDisk in this machine, and that is SDB, and SDB1 is mounted at home. So it makes perfect sense now. And if I get out of this, and let's go jump into this machine just real quick because I didn't run LS block on it. Let's take a look at that. And this one, you see we got a lot of stuff listed here. That's because this is an Ubuntu system. These are your snap packages. Not a big fan of how Ubuntu does this, but it is what it is. That's a topic for another video, and you'll see in this machine that we have 3 partitions on SDA as we looked at before. One of them right now is time shift is running on this machine, so it's showing that. But it is also at root. That's the backup software I'm using on this machine, showing that right there, so don't get too confused. And then here we have SDA2, which is a swap partition. It's showing that right there. And then 3 is the home drive. And it says there's another disk in here, STB, and it has 0 space. And it says there's nothing on it. Okay, that's weird. What is STB? I'm going to have to figure that out. There should only be 1 disk in that computer. Okay. Anyway, that's it for this video. Thank you for watching, boys and girls. I really don't know what that SDB is, to tell you the truth. That's the first time I've noticed that. Maybe there's another disk in that machine I forgot to take out. Or, you know what? That might be an old SD card in there too. I have no clue. Anyway, thank you for watching the video, boys and girls. I certainly do appreciate it. If you have any comments, suggestions, questions, please feel free to put them below. And we'll do it again real soon. And don't forget, if you like the video, share it. It helps an awful lot. And give it a like as well. That boosts them. Tells YouTube you liked it, and it suggests for other people. And you already know that. I don't need to tell you that. But every other YouTube creator out there does. So maybe I'll throw it in every now and again too. Please don't unsubscribe because I did that. Talk to you later.